do you know general systems theory? Do you understand the underlying principle of homeostasis, a steady state? Okay, so if we go in time, if we say 1 million years, we're going to go, this is 1 million years from here to here. And if we go to the glaciers and drill down and look at the bubbles of air, we can actually detect how much carbon dioxide and change in carbon dioxide over time. And looking at the Vostok ice coring and the European second dome, we can get a good historical record. And what we see is a range, this is parts per million. So over time, every 100,000 years, atmospheric carbon dioxide goes up and then down. Every 100,000 years, up and down, like this, okay? But it's every 100,000. So these are parameters. You would say this is a steady state, a range of behavior between parameters. This will go on forever, right? Unless there's an event. A different time scale, this is 12,000 years here. 12,000 years ago, it was actually like this. We were going back into another ice age. And humans on Earth, 12,000 years ago, discovered agriculture, plowing, breaking. If you think about breaking the soil, let me go back to this back here. Through agriculture, 12,000 years ago, we learned how to break the soil. And when we break the soil, microbes have access to this carbon. They eat it, and we see a biomass response because of the plant available nutrients, which are the waste product of microbes. So when we plow, all of a sudden, this fossil carbon is accessible for consumption by microbes. Their waste product are plant available nutrients. We get a response. This is why we plow. But we're burning up our fossil carbon. So 12,000 years ago, humans on Earth discovered plowing. And at that point in time, well, then I should explain what's happening here. Every 100,000 years, the Earth and the Sun get closer and go apart. It's not much, but it's enough, because as the planet cools, carbon levels increase in the atmosphere, and then when it warms, they lower. What's happening? What's the transfer? Turns out at that same time, this is air, carbon, this is plants. So every 100,000 years, as it gets cold, the plants die, and then it gets warm, they grow. That's where the carbon goes. So it goes back and forth between carbon pools every 100,000 years. It's the opposite. It's an inverse relationship. So 12,000 years ago, as water on Earth was being bound in ice to form glaciers, going into a new ice age, humans discovered agriculture, and there were enough humans now that it made a global impact. So in the Asias, rice was developed. The Americas, it was corn, and in Europe, it was wheat. So we have a global phenomenon of tillage that actually altered the climate. 12,000 years ago, there was a carbon management event, tillage, and rather than the atmospheric carbon being bound up in ice, it started to climb and increase. And it was because of an increase of vegetation to feed people. Now where is that carbon coming from? We've introduced a new source of carbon in terms of soil carbon, which is relatively stable. Now we're decreasing soil carbon through tillage to increase plant production, which is increasing atmospheric carbon, and it's going like this now. And then the fossil carbon, 200 years ago, we really figured out how to remove it. So the difference between this range of carbon here, 190, 290, we're up to 400 now. The difference between here and here, 1/3 of it is from biological processes, plowing. We can actually detect with isotopes in the air that the excess carbon, 1/3 of it is the result of biological processes, not burning. 2/3 is from burning. So fossil fuel deforestation, right? I get excited when I see this, because this shows me humans can manage carbon and change the climate. So how do we do that constructively? Let's manage our waste stream in a beneficial way to increase soil carbon, increase production of vegetation, and remove it from the atmosphere. And stop using fossil fuel, right? There it is. That's the big picture. So I was describing general systems theory, which is what this is. This is homeostasis, and then an event. And then it's homeoresis. It's looking for a new normal, right? And the problem is, in homeoresis, it becomes a feedback loop. The more that happens, the more happens. So it starts going, accelerating. So for us, what we want to do is introduce an event that has homeoresis find a new normal this way. And that's what our data shows. We knocked it once, and this happened. There was an event, compost. So compost ignited a state change in the soil system, and it's actually acting differently now. My disturbance from grazing was an event that knocked it in a new direction. So that, as humans, having a beneficial impact is our job. And the best way to do it is to organize and synchronize and harmonize, which is what meetings like this help us do. Did that answer your question?
I have to, I don't think I should ask them.